Hello everyone, my name is Daniel Downing and this is my presentation for the fuel system on the CRJ 200. And a quick summary of some of the topics that I'll be covering in this presentation of the fuel system of the CRJ 200. First, we'll talk about how fuel transfer is accomplished within the fuel system between the various tanks to the engine. We'll also talk about the overall flow diagram of how fuel flows from the various tanks to the engines. We'll also talk about fuel indications and how those are shown. And then we'll talk about the ICAS primary display, which is the engine indicating crew alerting system primary display. It's essentially showing all of the engine data. And then finally the ICAS secondary display, which is essentially going to show a pictorial representation of the fuel system and the status of the fuel system overall. So I'll kind of skip around and we'll cover all the aspects of the fuel system on the CRJ. So the first thing we'll talk about is fuel transfer. So fuel balance is done by gravity balance line and associated shutoff valves using the fuel control panel, which we'll go over a little bit later. The cross-flow in the APU pump is automatically controlled by the aircraft fuel system computer, or it can also be manually controlled from the fuel control panel. The aircraft fuel system computer will automatically begin a transfer when there's a fuel imbalance of 200 pounds between the main tanks and maintain until the imbalance decreases to 50 pounds. Also, imbalances of 800 pounds or more will result in an ICAS caution alert, or the engine indicating crew alerting system. There'll be a caution message on that screen. So to the left, we can see the fuel control panel. It's located on the overhead panel above the pilots, and it's located right there in the center on top. And then speaking a little bit more about fuel transfer from the center tank to the wing tank is automatically controlled by the aircraft's fuel system computer. So when there's an imbalance in the system, the pilots don't have to manually activate any of the cross-flow pumps or any of the fuel pumps in order to transfer fuel. The aircraft fuel system computer is going to take over and do that automatically. It's going to activate when the wing tanks decrease to 94% capacity. So as soon as they dip below that, essentially 90%, the aircraft fuel system computer is going to activate those pumps and it's going to automatically start to transfer fuel. So we can see at the diagram on the left the location of the various tanks installed on the aircraft. We can see that there is one center tank, there are two collector tanks, and then there is a main tank in each wing. So essentially the main tank is going to be our center tank. There's going to be two collector tanks, and these two collector tanks are located within this center tank, and they're going to remain full at all times. There's going to be two supply lines that are going to feed both engines from both of the collector tanks. So essentially either of the collector tanks can feed either one of the engines, and then vice versa. There's also a pump, so fuel is routed to the engines by two electric fuel boost pumps and the main ejectors in the engine. And the boost pumps are activated for all engine start procedures until the pressure builds up within the system, and then the main ejectors are going to take over from there. And then lastly, the APU. The APU is going to receive fuel directly from the main tanks via the cross-flow valve pump. And here's a better view of the fuel control panel that we were looking at earlier, and we can see that it is located on the overhead panel right in the center, just like we saw earlier. So for the switch boost pumps, both boost pumps can operate simultaneously and they can feed either engine. Pressing the push button is going to activate the boost pump and illuminate the switch light, so we can see that the left or right boost pump either on or off. And then we can also see the gravity crossflow and the automatic override crossflow for both systems. The boost pumps are automatically disconnected when the output pressure is sufficient to supply the engines via the main ejector pumps. And next we'll start talking about fuel quantity indications. So fuel quantity gauging system is a DC type capacitance system that indicates usable fuel. The fuel quantity probes, there's 6 in each main fuel tank and 3 in the center tank, and the compensator units, 1 per main tank, provide the fuel system computer with fuel quantity information. Furthermore, the computer is going to correct for airplane pitch and roll attitude. The computer is also going to present corrected information of individual tank quantities, total fuel quantity, and fuel used quantity to be displayed on the ICAS, which we'll cover next. The quantity is represented by 8-segment 4-digit LED numeric displays, which we can see to the left. We can see the fuel tank quantity display, as well as the mode selector switch and the refuel defuel shutoff valve switches on that panel. And next we'll cover the ICAS primary display. So the ICAS is the engine indicating and crew alerting system. It's basically going to provide the pilots with all of the necessary information about the engines. For example, we can see at the top, we can see N1 and N2, which is going to be basically the rotational information supplied by the engines. Is basically the RPM of the engine. We can also see the ITT. We can also see fuel flow, we can see oil temp, oil pressure. So there's just a lot of information about the engines, the essentially RPM information, and then a variety of fuel information as well. So we can see the ICAS primary display is going to show fuel quantity of the left and right tank. And there's also going to be readouts. So if there's a green readout, it's going to show that the fuel is balanced, while if there's an amber indication, it's going to show a fuel imbalance of 800 pounds. Next, we have the center tank. So on the ICAS, the center tank is going to show fuel quantity of that center tank. And there's also going to be readouts for that as well. Green is going to represent a fuel quantity in that tank of greater than 10 pounds, while white is going to represent less than 10 pounds. And then next we have total fuel. So the ICAS primary display is going to show total fuel quantity of all tanks. So the readouts are going to be green is going to be greater than 900 pounds in that tank. Amber is going to represent less than 900 pounds. And then magenta is going to represent a low fuel detection invalid. So the data is going to be invalid in that tank. And then next we have fuel flow. So lastly, fuel flow, green is going to represent less than 5,000 pounds per hour being burned from the engines, and then amber is going to represent greater than 5,000 pounds being burned per hour. And lastly, we'll discuss the ICAS secondary display. So the primary display is going to show the different types of engine information, like we said, oil temp, oil pressure, the N1, N2, ITT, and then some fuel information. And then the ICAS secondary display is going to kind of show the overall status of the system. So green is going to show normal, and amber will show abnormal somewhere in the system. So we can see overall it's just a pictorial representation of the fuel system as a whole. So some of the things that we can see on here is going to be total fuel quantity. We're going to see the APU pump, whether it's activated by the cross flow transfer system, and we can see whether that pump is active or not. We're also going to see fuel temperature in each of the various tanks. We're going to see the left and right tank fuel quantity, which we can see to the left and right just there. We're going to see the status of the boost pumps, so whether those are active or not. Fuel use quantity, so how much fuel has been used throughout the flight since the aircraft's been on. We're going to see the center tank quantity, the status of the fuel lines, so we can see that the various fuel lines are in green, again representing normal system operation. We're going to see the fuel filter, the transfer valves, whether those are on or not, and then the shutoff valves as well.